All right, so we have a radioactive substance and it decays over time, right? It's radioactivity. And sometimes they give you bizarre units. That's why I wanted this included. Like whatever units they give you, you go with it, okay? Time is my x, which goes into L1. It's going to be crucial. The one we do after this, which is logarithmic, I want to make sure you understand that the first is always x, the second one is always y. The reason I'm saying that is because you're going to start seeing time here. It's going to be your y variable at times. Not always, very rare, but it does happen. Okay? Stick with this, it never changes. Determine the exponential equation. So you're being told it's the exponential equation. So, what am I doing here? So, yeah, stat, calc, exponential regression. I will just quickly enter that in here. So 0, 3, 6, 9, 12. Be careful. This isn't always going to be consistent. Okay, so watch carefully. 450.91. 378.52. I'm going to ask you to verify here that the equation is actually what it's supposed to be. I think we're good. I'm going to do a scatter plot. See, I want you to look at the plot. Zoom 9. Oops. Plot 1 has to be on or else nothing happens. Zoom 9. So you can tell that it's a decreasing function here. I'm going to change my window a little bit. The negatives here. I'll go to 500. It's a pretty good one. Now I'm going to do my regression. And there you go. That's what I'm supposed to be seeing here. So y is equal to 451.05, 0.9431 to the power of x. 94 is fine. Okay, so you're good to go. What is the percent change per hour? That you take it from here. Okay, so you go 1 minus 0.9431. That is 0.0569. That would be 5.69%. That is for me. If you went 0.94, then yours is just 6%, right? How long will it take for the radiation? Until the radiation drops to a level of 100 BQ, okay? 100 BQ, so that's my Y, okay? So they're asking how long until this is 100. So I'll do y2 is equal to 100. Second, trace, intersect. I can probably make this work. Yeah, I knew that I was going to have to increase my x max. I'm going to go 50 there. And until I see the intersection, enter, enter, enter. That's 25.71. Okay, 25.71 hours in this case. Circle that. That is your final answer for C. What's the half-life? Very important. Decay, we're talking half-life. Let Y2 be literally, this is where Danica was asking me earlier. Sorry, not to put you on the spot. I actually appreciated that question. Which one are we supposed to take? Because my initial could be that, or my initial could be this. And I will say, regardless of which one you used, if you show me the work, you get full marks. Chances are, if this is being asked, you're not going to have a choice. Like we're just going to give you the equation, so you're just going to base it off of the equation, okay? But this is a valid point, and why are they different? Because this regression tries to fit all of these points as best as possible, and sometimes that means changing this, okay? So we'll let, I'm going to go by the equation, 451.05 divided by 2. And then we go second, trace, intersect. So I'm actually going to go to y equals, and I'm going to put that in brackets and go 451.05 divided by 2 like that. You hit graph. And there it is. Okay, second trace 5, enter, enter, enter. That's 11.83 hours. 11.83 hours. Yes?
I got 11.8.
Did you use the, just a couple of things. Did you use this number and split this in half, or did you use the 450 and split that in half? Like as your Y2?
Oh, I think I used the 450.
Okay, so that's fine. Yeah. How much radioactivity will be present in 4 days? 4 days is 4 days times 24. That's 96 hours. Oops. You can't see that. It's 96 hours. You can't do days, right? Got to go hours. So they're saying when X is 96, what is Y? So we're going to go second, trace, intersect, and not intersect, sorry. It's an off day today. I don't know what it is. Second trace. I made several mistakes on the previous class, so be warned. Okay, 96. They hired me to make sure students know that even if you're not perfect, you still get to be hired. Yeah. What happened? 96, I'm panicking. What's happening? The thing that's happening is that you can't see it based on your window. So X max has to be, I'm going to go 120. And then I'm going to go second trace 1, 96. Try it again. There it is. 1.63. 1.63 BQ. It's like a barbecue or something. Anybody know what BQ stands for? Anybody like in chemistry? Barbecue? It's 1.63 barbecues. Okay, Hezon, putting you on the spot. He did this. And there's nothing wrong with this. Okay, took his equation. Did you round to 2 decimals though? 94?
Yeah.
Okay. He went like this. He inserted X into his equation, put 96, and then calculated it that way. What happens is when you raise something to the power of 96, I should have explained and make sure you understand this. What is happening is it's 0.94 times 0.94 times 0.94. How many times? 96 times. If you do this 96 times, and you might think at first, oh, 94 versus 0.943, like what's the big deal? Over a long period of time, being off by just a little bit, it actually makes a big difference in the long run, right? If you're doing this 96 times, if you only do it like after 4 hours, after 10 hours, you're not going to notice the difference. But 96 hours, now you're doing like 96 iterations, right? You're doing this 96 times. That's why the answer is different. What do you get his own? 1.19 BQs? So what do we do with that? I would honor it. I would honor that. That's a valid strategy to just substitute. But I think if you want to, I was joking, if you want to launch a rocket into space, you probably want to use all of the decimals you have in your calculator, right? That's going to be the best way to do it. So I would say it's better to use second trace value because it includes all of the decimals. It's much more accurate, okay? So That is just something that occurs from time to time, and that's, I guess, where significant values come in, right? In the long run, that does make a difference, okay? So, 1, 2, 3, 4, 5. This one is just worth 5. So,